Hi all. About 25 years ago, I started working on an image and vector viewer, and I have been working on it to and fro for the last 25 years. I realized I've never given a presentation about it, so I thought it is about time. It is cross-platform. It works under Linux and Windows, and I'll show you some of the special capabilities it has. So what I'm going to do is just run through the examples in the uh, give example directory. So this is an image which is composed of a, a vector layer, and if you press the Marks browser, you can see the different layers you have, data sets you have, and you can toggle everyone on and off. And one of the things you can do, if you press the B button, B is in balloon, and when you hover above a data set, it will show you which data set it is above. And this is quite useful for vision algorithms. We'll see that in some other examples. Okay, let's go on. This is an example of having a background image. This is the ubiquitous Lena image. In the last few years, it has become quite non-PC to show this image, but it I introduced it as an example back in the good old days. Again, here you have the original image, and then you have data sets, and you can see that you have alpha transparencies and colors and so on. And in the future, I'll either in this lecture or the next lecture, I'll show you how to create these data sets. It's quite simple. Okay, another example, more or less the same. Here you can see you also have arrows, and again, when you hover above the data set, it will show you the text that belongs to it. This is an image of my cat. She was called Maya, and you can see here you have some algorithm that has developed that was used in one of my previous companies, which shows the boundary between the dark and the bright areas, and you can see that the algorithm finds the border on a sub-pixel level, and this is very nicely shown with GIF. As you can see here, these are the pixels. You can also turn on you can also turn on the pixel grid. Here you have the pixel grid, and let's turn that off. And you can see how the algorithm finds the border on a subpixel level. So this visualization is very nice in contrast to the recommended visualization with OpenCV, for example, which just paints pixels inside the image. And if you have some algorithm which is sub-pixel accuracy, you won't be able to see that if all you're doing is painting the pixels in the image. All right, so just a closed paths. We'll see more about paths later on. Yeah, colors and some more examples. Yeah, here you have also an example of various text you can show also with you also have the ability of setting an anchor for the text, so you can show text either anchored to the left or to the right or to top or bottom and so on. You also have like dashed lines and some more examples. Um, okay, so yeah, more or less the same here. I have Lena again. Yeah, these are not very sorted, these examples. Uh, this is an image of a it's a FITS image, and this is a 16-bit image, should be at least. And let's see if I can do the adjust contrast. Yeah, and now you can change the contrast of the image. You can see this is the window of the contrast from 34th or 3095, and you can move the window back and forth. Another thing you have in GIF, you have You have color tables. So let's show, for example, a rainbow, and then you can get false coloring of the image, which is nice for, it's very nice for scientific images. And let's turn that off. It's the view and color table none. Yeah. Here, this is an example of multi-image, which is also nice. You can reference images inside the you can reference images inside the GIF file, and then you can go through them by pressing the up and down arrows. You can have the same overlay on top of different images. This is also nice when for scientific images, when you have images coming from different modalities or from different time points, and then you can still show the same overlay on top of the images and go back and forth between the different images. Yeah, this is an example of a Bezier path, and here you also have the fold balloon that you can have rich text in the balloons. You can see the name of the dataset here is dataset 0. This is the path, but the balloon contents is much richer. So we'll see some examples of this well later on. Yeah, polygons with holes. It's a quadratic Bezier curve. And you also have quiver plots, which are nice. So you can change the strength of the arrow. This is nice for showing vector fields. And again, you can have, let's see, yeah, you have the data set is shown when you hover above the image. Oh, this is not working. You should be able to have SVG files as marks as well. It's not working right now. Yeah, this is the text align. This is the number, which is kind of like on the numerical keyboard, which shows you which direction you're aligning. You can also put the text at an angle, and this is how it comes out. More rich text. Yeah, so this is just using Unicode. There's no, yeah, it's using Unicode and Pango markup, which is a markup language based on the toolkit GTK, which I'm using in GIF. Yeah, this is another algorithm which is nice, and this is a Voronoi, and you can here toggle either the lines or the sites, and here you can see how you can name various parts of the algorithms and then toggle them on and off in order to investigate what's happening. Yep. So that's all I wanted to show for this time, and next time I'll if there's interest, I'll be happy to show you a bit about the text format which GIF is based on, and I'll also give a link in the description to the to GIF's repo that includes releases both for compiling under Linux and installers for Windows. That's it for this time. Bye bye.